Okay. So earlier what we discussed that this is a graphical section of a member where load is acting. Okay, this load is acting in uniaxial direction P, and these are the forces generated. This is the external load and this is the internal forces generated in the member, which is normal stress, normal stress and shear force, shear stress. N is represented by normal force. Don't get confused with these words. N is your normal force. N is your normal force and V is your shear force. And sigma is your normal stress and tau is your shear stress. So we at first we found out a relation between a non-transverse area and transverse area. Okay. Then we got a relation A equals to AT by cos theta. Hope this part is clear to you all. Then with this A, we know, and we know, let me note. My screen is visible, right? And my cursor is moving. Yes or no? Everything is synchronizing now?
Yes, ma'am.
Okay. So we know sigma is equals to, this color is very light. Let me choose another color. So we know sigma is equal to n by a. So with that we found out the value of n, which is we got sigma at by cos theta. In a similar way, we know tau is equals to v by a. We put the value. We put the value. Don't write your roll numbers now, okay? I won't take your attendance now. So your tau is your v by a. So put the value of a, at by cos theta. We got the tau. We got the v value from this relation. Tau at by cos theta. This tau at by cos theta. So we got n and v. We got normal force. We got shear force. Then next, why it is not moving? Just wait for a second. Why it is not moving? Okay. So from here we got n and v value. N and v value. Then after getting this n and v value, we have taken the equilibrium condition and we got the relation between n and p and v and p. So this is our relation for tau. This we got a relation. We got a relation of sigma and p in this format. We got a relation for tau and p in this way. Any confusion with this part, or should I explain this part once more? Please respond.
Okay.
Once more, ma'am.
Okay. So now we have value of n, we have value of v, we have p. Now we have to equilibrium the forces. Okay. See, this is in the horizontal direction, so I cannot equate, and we don't have horizontal direction and force in this direction. So I cannot equate, cannot take the equilibrium of these forces. So here I have, and most importantly, we need n and v. So we have to resolve this p into this direction and this direction, into perpendicular direction and parallel direction. So we can resolve p in this direction and this direction. So we can assume that P is the resultant of this force and this force. So I'm assuming theta is making here. So with theta, this will always become your P cos theta. If the force was N, so this will become N cos theta. If the force is X, it will become X cos theta. So main purpose is this will be a cos theta and the perpendicular to this will be your P sin theta. This will be your P sin theta. Now I equilibrium all. Now I equate all the forces in perpendicular directions. Summation of forces in perpendicular direction is equals to 0. in perpendicular direction I'm taking as equals to 0. So this is one perpendicular forces, I'm taking it as positive. On this surface, this is one perpendicular forces. See, here direction is this way. Why this way? Because this is going outward, so this will be will also go in the outward direction. So direction of this in this direction, again this and the direction of this force in this direction. So it will be this. If I'm taking this one n as positive, I'll take this one as negative. This is nothing but negative. So n p cos theta equals to 0, or I can write n equals to p cos theta, right? And we know the value of n is sigma 80 by cos theta. So put the value of n as sigma 80 by cos theta, and here we have p cos theta. So if I want to get a sigma, what will be the value? P, this cos theta will go to this side and it will become cos square theta divided by this 80 will comes to here. So we got the value of sigma as p cos square theta by 80. This part is clear? Yes or no? Perpendicular, we are taking summation of all the perpendicular forces equals to 0. So this one, what are the perpendicular forces acting? This one and this one. So I am taking n as positive, so I have taken n minus, I am taking this one as the negative direction, so I am taking as n minus p cos theta equals to 0. This is minus, it will become positive if it goes in this direction. Put the value of n as sigma 80 by cos theta here, sigma 80 by cos theta, and find out the value of sigma. This will goes in this direction, so we got sigma equals to p cos square theta by 80. Hope this part is clear. Yes? Respond. I need response. Without that.
Yes, ma'am.
Okay. So let's move to this perpendicular forces is we got from the perpendicular forces we got sigma value. Now from the parallel, I'm taking summation of all parallel forces equals to 0. So what are the parallel forces to the cut surface? One is this direction, another we got here in this direction. P sin theta. This was our P sin theta. So I'm taking suppose I'm taking P sin theta as positive and V as negative. So I'm writing P sin theta minus V equals to 0. Okay. Now this becomes P sin theta equals to V. And we know what is the value of V. Earlier we got tau 80 by cos theta. So write tau 80 by cos theta. And earlier, now here we have P sin theta already. We have P sin theta already. So if I want to find the value of tau, what will happen? This cos theta will go in this direction. So we will have sin theta into cos theta. P sin theta into cos theta divided by 80. And if you are familiar with the trigonometric, this sin theta and cos theta can be written as half of sin 2 theta. So we'll replace with that. We'll replace the sin theta and cos theta by half of sin 2 theta. So our formula will become P sin 2 theta divided by twice of 80. So this is what we got. Tau equals to P by twice 80 sin 2 theta. Clear? Is this part is clear? We got tau equals to P sin 2 theta by 280. Please respond, student. This part is clear or not? Hello?
Ma'am.
Clear? Yes, okay. I got Y. So hope this is clear. Where to cancel? Just wait. Now let's move to the next part. So we got sigma is equal to P cos square theta by 80.
Excuse me, ma'am.
P twice 80 by P2 sin theta twice 80. So what was our aim? To find the normal stress, maximum normal stress and shear stress. We got the value of normal stress and shear stress due to external loading. If you recall the first class, what we have discussed, we will apply the external load and will get the internal loads on that member. So we have applied the external load P and we got this internal load, internal action. As it say now, every action has equal and opposite reaction. So this was the force, and these are the internal forces generated. So we got sigma and tau because of this external load, right? Now we'll find when this values will be maximum. Anyone idea when this cos theta, when this value will be maximum? And okay, before that, just tell me what value it will depend to be maximum. Means when this what are the members it will affect its maximum value of sigma. This is sigma, okay, this is sigma. What will be the in P A cos angle, what it will affect its maximum value? Respond. What will affect its maximum value? Hello, my voice is clear now? Hello. Okay.
Yes, ma'am.
Okay. So tell me, what will give its maximum value? When can I say that sigma will be maximum? Whether it depend on P, AT, what? Respond. See, it will depend on this. Neither it will depend on the P, neither it depend on the A. It will depend on the theta. Why? See, this is the theta, right? Inclined plane. This inclined, say this angle can be inclined in 45 degree. This angle can this plane can incline in 90 degree or 135 degree. So inclination will depend on what? Theta. It will depend on angle or not? Yes or no? I assume it's yes, because no one respond. So this theta will depend its inclination. It can be 10 degree, it can be 20, 30, 35, 65, whatever it will be, inclination. This stress will depend on its theta. Same with shear stress. This shear stress will depend on its theta. So its maximum values also depend on theta. So when this angle will becomes maximum, whenever this cos theta give maximum, this will be maximum. So for cos, we know cos function. How is the curve for cos function? Section A students are more active than you guys. No one responds. Anyone remember the sign cos function? It is like somewhat like this. Here the angle is 0 degree. Here the angle is 90 degree. Here the angle is 180 degree. So when this curve is maximum, either it is maximum at 0 degree, either it is maximum at 180 degree. Okay. So your sigma will be maximum when the angle will be 0 degree. So sigma max when theta will be your 0 degree or 90 or 180 degree, sorry. It will be 180 So your theta will be, sigma max will be maximum when theta is equal to 0 degree. Look so bad. Let me remove this. Let me remove this part. So your sigma will be maximum at which angle? When your theta will be 0 degree. See, the curve is maximum at 0 degree. Again at 90 degree it downfalls. Again at 180 degree it becomes maximum. So your theta will, when your theta will be 0 degree, you will get maximum sigma, or at 180 degree. Okay, so if I put cos theta equal to 0, what will be the sigma value? Write it down in your copy and tell me the answer. Write in your copy and tell me the answer, or calculator. Use your calculator. What is the value of cos theta? 0. What is the value of, if I put cos theta in place of theta, if I put a 0 value, what will be the value? Am I audible? Hello? Hello? Am I audible?
Yes, ma'am.
So what? Okay, 1. Good. So 1. So it sigma will becomes P by 80. So this is the maximum value. The students are still coming. All are in waiting. Okay. So sigma will be maximum when the theta will be 0 or 180 degree. See, if you compare, if you put another value, you won't get the maximum value comparison to these two values. In the same way, for shear stress, how's the sine function works? How's the sine curve? Anyone remember sine function? So it is somewhat like this. It starts with 0 here. So at 0 it is not maximum, at this will be maximum at 90 degree. Here it will be 180 and here it will be somewhat 270, I guess. Yes, 270 it will be. So your in sine function, your value will be maximum at 90 degree. But there is a theta. Theta will be 90 degree, but we have here 2 theta. So your 2 theta is your 90 degree. So your theta will be how much? 45 degree. Same way, 2 theta is 270 degree. And half of 270 will be how much? 135 degree. So your tau max will be maximum when your theta is your 45 degree and 135 degree. Now there is one important point to note. The sign of shear stress changes when theta becomes 90 degree. Not in case of shear. Sorry, in normal stress. In shear stress, the sign is changes. Suppose when the theta is in between, I told you na, the inclination will affect these two values. So when the theta is less than 90 degree, the direction of normal stress will be this, and shear stress will be in this direction. But when the angle becomes more than 90 degree, your shear stress will come to upward direction. Normal stress will be same like that. It will be perpendicular to the cut surface always, but the direction of shear stress will change. The most important result from this part, or this from this, a gate question came, I don't remember the year. From the whole explanation, one is important is you should know about this thing. Tau max, when will be your sigma max? Magnitude of sigma max is how much? How much it will be the magnitude of sigma max? Let me remove this part. It becomes so. Magnitude of sigma max. If I put here 0, I told you na sigma will be max at 0, theta is equal to 0 degree. If I put theta, cos 0 is your 1. So I'll get P by 80. So your magnitude of sigma max will be P by 80. Again, if I put here theta is equal to 45 degree, this will become maximum. This will become 1. So it will be P by twice 80. So I can write twice of magnitude of tau max. I can write or not? I can write this relation or not? Magnitude of sigma max is P by 80. If I put here theta equal to 0 degree, I'll get P by 80 magnitude. Magnitude means removing the angle part. If you put the value of angle, then magnitude will be your P by 80 into what will be the tau max? Tau max is, if I put here 45 degree, I'll get 1. So P by twice 80. P by twice 80. Right? So if I write 2 here, this 2 and 2 will be cancelled out, right? And this P by 80 will become P by 80. So your P by 80 is what? Sigma max is equal to twice into this whole thing is what? Tau max. Clear this part? This part is clear? Please respond.
Yes, ma'am.
So your magnitude of tau max is nothing but equals to twice of tau max. How does twice max comes? If you put the value of tau max, you will get P by twice 80. So to become this and this equal, I am multiplying this with 2. 2 will cancel this, then this part and this part becomes equal. P by 80, P by 80. And P by twice 80 is nothing but magnitude of tau max. So tau max equals to P. So here important relation is magnitude of sigma max equals to twice of magnitude of tau max. Hope this part is clear. And remember this part. When there can be an MCQ question, like in first in sessional exam, that when the sign of shear stress changes, when theta is more than 90 degree, when theta is more than 30 degree, or theta is more than 100 degree, like this. Question may come in that way. Okay. So go through. So see, as all the means due to pandemic, might be classes will go on like this. Okay. So might be again there will be there may be an online exam. I won't comment on that. So go for MCQ questions more now for the time being, and go through all these derivations I have discussed. So what we today we discussed till now? We discussed how to find the maximum normal and shear stress on inclined plane. We found out the relation between A and AT. We got this relation. From those relations we found out the value of N and V by the formula sigma is equal to N by A, tau is equal to V by A. Then after finding the N and V, we relate this N and V with P, and we found out the relation between sigma and P. We found out a relation between sigma and P and tau and P. So these are the two relations. We got the normal stress and shear stress in terms of P and this angle. Now we found out when this value will be maximum. So when the theta will be 40 when the theta will be 0 and 180 degree, then your normal stress will be maximum. And when the theta will be 45 degree and 135 degree, your tau stress will be maximum. Okay. So I want you all to write this question, practice this question. What is given here? For a simple model of engineering structure shown, the bar B is a 50 mm diameter round steel bar. So this is a structure. Neglect all the weight. Just you have to consider this section BE. You have to draw a free body diagram for this BE and found out why people are in waiting. Okay, sorry for the inconvenience. Okay, So this is your member BE. You have to find out, for this member first you have to find out the normal stress. For the transverse cut you have to find out the normal stress in this member. Again, for the non-transverse cut at an angle of 30 degree, you have to find out the normal stress and the shear stress in the member of BE. And the dimension of dimension of the member is given as it is 50 mm diameter. Okay, so I'll give a hint. You have to draw a free body diagram and you have to find out a P force. Your first step is to find out the P force. Use your concept of free body diagram and to find the forces you have used in truss members in your engineering mechanics. I'll just give you an example. Just find out the P value in this member, then everything will become easy as we discussed till now here. But the first step is to find out the P value. What will be the force in this member? Axial force in this member. Okay. Find out the axial force in this member, then the rest will be same as we have done in the earlier classes, and we have done numerical also. It will be same like that. Hope all of you have wrote this question. लिखा questions लिखा yes, someone is saying something. Write this question. For a simple model of the engineering structure shown, the bar B is a 50 mm diameter round steel bar. Just neglect the weight of the individual members and the wheel in your analysis. Forget about the wheel and other members. Just find out, the first hint will be you have to find out the force in the member BE. After you find out the force in the member BE, then you will automatically able to find out the transverse cut of the bar. Due to transverse cut of the bar, how much will be the normal stress in the member BE and how much will be the non-transverse cut, how much will be the normal stress and shear stress in the member BE at an angle when the cut is in 30-degree direction. Hope everyone have wrote their questions. Those who have not written, please take from your friends. I'll give the solution also. And when I'll share the PPT, I'll give you the solution also. We have time, I guess. Yes, we have time. So let's move to the next class. Hope my screen is visible. Yes or no?
Ma'am.
Okay. So the main, I'm teaching you, every class has a module. Okay. Every class will have some learning outcomes. So in this class we have defined the state of stress at a point define the state of stress at a point in 3 dimensions and the sign convention of the state of stress at in 3D direction. Means we'll study the 3D body. So general 3D state of stress at a point. Suppose this is a complicated body. Okay. These are the different forces acting on this body. F1, F2, F3, F4, F5, F6. There are different forces. Remember, when I took a section from that in inclined plane, I have assumed that stress is uniformly loaded over that section. Remember, I have taken a section. Let me note. This was our section. I have cut in some transverse direction, and I've shown you this transverse direction in this direction. Forces were acting. This was the shear stress per parallel. This was the normal stress. We have assumed that stress in all the direction is same. Okay, but if you take a structure, for more complicated structure, remember the stress distribution may not be uniform or arbitrary on arbitrary planes. Suppose take a steel bar. Okay, if I applied a stress on, if I hit the steel bar, the stress we applied may not be uniform all over the section. Okay, suppose there is a long steel bar. You are hitting at one point. the stress getting on that point may be 100 MPa, but the stress on the and the front end and the last end may not be 100 MPa. Are you getting my point? Earlier we have taken a small section and we have assumed that the stress on that area is uniform all over the structure. But if you take a long complicated structure, suppose you take a bridge, you take a dam, you can take any structure. So suppose if you apply a load on a particular place, the stress generated on that area may not be equal to other areas. Suppose this is our structure, I'm applying a force on this member, okay? I'm applying a force in the whole structure, I'm applying a force only in here. So whatever the stress generating here due to the force may not be equal to this part, okay? So this is the point. For more complicated structure members, the stress distribution may not be uniform on arbitrary planes, okay? For an infinitely small point, the stress distribution approaches uniformity. I'm talking the same point. For a large body, I have taken a small part of that body. Suppose this is the whole large body. This is the whole large body. I have taken a small part. I've taken out a small part, and we can assume that the stress distribution in the whole part is same, but the stress in the whole big area cannot be same. Stress generated on the whole body cannot be uniform. Okay, hope that you are clear with the word uniform and non-uniform. And uniform is equally distributed. So this first point is explaining you for more complicated structural members, the different structural members, beam of a house, a column of a house, a portion of bridge, portion of dam, any structure. So the stress distribution may not be uniform, okay, but for an infinitesimally small point, this is suppose this is a bridge in the form of square. I'm taking a small, very small, infinitely small means you cannot see it all, see also. So for that point, the stress distribution is assumed to be uniform. An infinite number of planes can be passed through each point. There are different points. This is one plane, this is one plane, this is one plane, okay. There are infinite planes on a structure, but it can be shown that three mutually perpendicular plane is sufficient to completely describe the state of stress at any point for any stress, okay. Suppose, let me rub this part. Please note this 3 points, very important points. So this is one small body of a structure. This is small portion of a whole large structure I've taken. If we take three planes, one plane, second plane, and three planes, the stress generated on these three planes will be sufficient to describe the state of stress going through in this whole section. Am I making more confused you by starting new lecture? Please respond. Hello?
Yes, ma'am.
Getting confused?
Yes, ma'am.
Okay, I'll discuss in the next class. I'll stop share my screen. All of you write your roll numbers in the chat box. Go through the class we have gone through. What we have found out today? We found out that what will be the maximum normal stress and maximum shear stress on an inclined plane. All of you write your roll number. join by your name. Okay, it will name and roll number, like name, then your just 07090, and it will be easy for me to note down. It becomes easy for me. In the chat box, write your whole roll number, but join with your name and your roll number. So it becomes easy for me to track down. And don't, you cannot write, you cannot give proxy here, huh? I have a track record of everything. So what are the topics we have wrote? Please write in your copy. Please write in your copy. Otherwise you will forget. Or you can do. If you don't want to make a note, make a folder of my PPTs in a download all the PPTs given by me. Make a folder and revise it. These are very small PPT. It will be easy for you to study daily. I'm discussing very leniently every single topic. Hope everyone wrote their roll number. It was 68 last who wrote. Motiur Rahman Chaudhary. Hope everyone wrote their roll number.
Ma'am, 68 present.
Yes, I have written. I've seen your roll number. That is the last one.
Yes.
All of you wrote their roll number. Any confusion from today's class? Let me share my screen again. Any confusion? Any derivation? You didn't understood? Please ask your doubt. If no doubts, then you have not understood, I guess. Any question? No. Response. Any doubt and all. Iba. Tash, why are you so late in writing your roll number? Any confusion? From this part, how you got A equals to 80 by cos theta, how you got N. I'll take a surprise exam also. So keep revising your things. Online exam. Hope everything is clear. Write yes in the chat box if everything is clear. From this part to this part to this part. My screen is visible, I guess. Okay. No doubts means no doubts means everything is clear. I'm stopped sharing my screen. Okay. Thank you. I'm ending the meeting.